next one I had was refrigerant pipe insulation. So when you're looking at a pipe schematic, if you've got a, say, a VRV system and you've got fan coil units all over the place, or it may be just a DX job, pipe insulation, are you familiar with how you work this out for the refrigerant pipes?
No.
Right, so in your, I've got something here that I'll show you, and I can send it to you so you can, I'm not sure where it is. Well, I know that there's one thing in your file. I'm just trying to find it. So, okay, if I go here, not that one. Philip sent me this document this morning. Can you see that?
Yep.
So it tells you the pipe sizes, and the minimum insulation thickness you need if you're using, are you familiar with Armaflex insulation, the rubber sort of insulation? So this column on the right-hand side is the thickness that you would have to select to comply with the NCC. Okay, so Philip sent me that this morning. I don't know where it is in the system. He's obviously taken it from a particular job. So I'll send you a copy of that so you can keep it for yourself. But there's also in your files, there's this document, which is the Armaflex insulation data. And you'll be able to find this in the files if you want to get more information. So your files have changed a bit, so you might have to have a bit of a hunt around. But so this is Armaflex. If you go down to where it's highlighted, basically this is saying the same thing as Philip's summary says. So it's easier to refer to Philip's summary because it tells you what thicknesses you need for certain pipe sizes. The NCC says that you, for cooling, you have to have an R value of 1, but for heating, you have to have an R value of 1.7. So this chart, the highlighted numbers comply with that. Are you familiar with the NCC?
Yes. Section J.
Yeah.
Just a questions on pipe insulation. Is it there? Because it is only DX, so the material doesn't matter. It is only fixed. Like, we don't need to change it based on the space or area that it is serving, right? It's just like the material of the insulation.
Well, for DX equipment, it's always going to be the what Armaflex type insulation, which is and I think they call it elastomeric. It's like a rubber closed cell insulation, flexible rubber insulation, which has a vapor barrier as well. So you have to have a vapor barrier. Do you know what I mean by that? Because it's in the cooling mode, because the pipe is cold, if the air around it is warmer or warm and humid, then you'll get condensation occurring on the insulation if you don't have a vapor barrier. Oh, sorry, condensation occurring on the pipe if your insulation doesn't have a vapor barrier. So, but the Armaflex style, Armaflex is a brand name, but that style of insulation comes with a vapor barrier. If you're using polystyrene or fiberglass, then you have to have an applied vapor barrier, which is a foil wrapping. So you've probably seen that. It's covered in foil and it's sealed at the joints so that that stops the vapor migrating through the insulation onto the pipe. So that's important to remember. And if you look at the NCC, it says you must have a vapor barrier as well as insulation with the R value that's specified. So I just wanted to mention that to you. Be aware of that because that's something that you'll be dealing with as you work through your design. You're going to need to know the insulation type and thickness. The next one I highlighted was the schedule of outside air and the exhaust ventilation requirements. Now, I did mention this last time. When you start your heat loads, you looked at the architectural drawings. You need to know what the outside air requirements are going to be, obviously, but you also need to know what the exhaust requirements are. So it's better if you make a schedule and And then you can also balance your airflows in the space. So if you've got more exhaust than outside air, then you're going to have to increase the outside air possibly to make up for the exhaust. And that outside air value has to go into your heat load calculations so that you've got enough outside air to make up to the exhaust and balance the pressure in the space. So that's an important step in your heat loads. And also you need to have a schedule of all the ventilation requirements. On a small job, like, you might be doing an apartment, it's probably not really relevant because you've got a toilet exhaust, which might be a separate system or part of a bigger system. You might have a small kitchen exhaust, so there's not much involved. But on a larger job, like an office, you might have printing areas, you might have stores that they need ventilation for. You need to take all that into account so that you've got enough outside air coming in to make up to that. And I'm just saying this now because I think it's relevant to what the work you're doing with the heat loads.
But it needs to be like a positive or negative, depends on the type of space, right? Like storage room, like exhaust systems, it should be negative type of space.
Yes. So if it's just, let's say it's an office space, generally you'd aim for a slightly positive pressure because you want to stop infiltration coming in. So if you have a positive pressure, there's a bit of leakage to the outside, which stops the unconditioned air sneaking into the building. If you have an area like a laboratory or might be an operating theatre, those sorts of special areas, they may operate under, well, positive or negative. So you need to know what the requirements of the space are. And
so basically, Peter, just a question. I will just see first if it is an office, okay, this space should be a positive one, like slightly positive. So I just need to calculate first the exhaust requirement and the outside air. And if the outside air requirement should be higher than the exhaust, then that will be the input details on our heat load.
Yep.
Okay.
Correct. Yep. That's exactly right. So if you want a positive pressure, you've got to have a bit more outside air than exhaust.
Okay.
Yep. Okay. So you understand that. So the next step in the process is to, well, I would suggest preparing a drawing markup. If you've already got a drawing and you've done your heat load calcs and you've worked out the airflows, then you can mark up the drawings. And it's always good to have an airflow schematic so you know where the air is going, where it's coming from, particularly with outside air or supply air, outside air, exhaust, return air, all of those things. It just helps to give you a good picture of the whole job. Duct sizing, you've done duct sizing. You know how to do that.
Yep.
Do you know the requirements of the NCC from Section J for ductwork?
Yeah.
And
the maximum PA per meter is 1, but we usually use 0.8.
Yep. Okay.
Then the velocity depends on type of the room, right? Because there's a noise rating requirement on each type of space, like office, like the higher the velocity, I think the noisier. So the velocity will be depends on the office, like the type of space, the main ductwork and branch.
Yeah, that's correct. Yep. Okay. And value engineering, I don't know whether you've done much on that.
But I got questions, Peter, on kitchen exhaust ductwork. How do you usually the velocity of that one, the kitchen exhaust riser? Is it like 8? Because it's not included in the AS 1668. Do you have like a preferred velocity?
Yeah, but it really should be a minimum of 8 meters a second. If you've got a very small duct, then that might be just way too high. But for the main duct, to carry the grease away, 8 meters a second is usually the figure. You'll see in the NCC that some systems are exempt from that pressure requirement, the 1 Pascal per metre. Kitchen exhaust is one of them. So you don't have to comply with the NCC for kitchen exhaust, and for smoke exhaust and things like that, emergency systems. But for general air conditioning, they set the limit to try and reduce the energy consumption in an air conditioning system, but a special exhaust system is a different thing. And there is an exemption in the NCC for that. So, and I mentioned VE there because, and I'll show you something I've got here. Now, this is not a MEPEC document. This is something of mine that I did back in 2016. So it's it's not up to date, but for ductwork, there's a few things there, and I can send you a copy of this if you like, just so you can have a look at it. Philip and Ivan and I used to work together, so all these things won't be new to them. We've all worked on these things together, and they might have more things. I've had a look through the file, and I can't see anything at the moment, but Philip and Ivan have probably got something. But these are the sorts of things to have a think about when you're doing your duct design, and you've probably been through some of these sort of things. But so just quickly, resizing duct based on pascals per metre. We just talked about that. Some manufacturers have ductwork manufacturing standards. And if they do, like particularly for small duct sizes, instead of having a range of sizes, make them all the same. If they've got a standard that says 250 by 250, I can make thousands of those rather than making different sizes around that, like 300 by 200 or something like that. They might want to make it all the same. So you have to talk to your client to see whether they have that sort of preference to do, because then they can save money. If when they produce duct, I don't know whether you've been to a duct factory, but they most of them these days it's automated. So from your drawings, it'll go to a computer-aided manufacturing program, and then the machinery will start to make the duct. It's just automatic. So once they set it up for a certain size, if they set it up for say 250 by 250 or whatever it may be, it just punches it out. It just keeps coming out. And it's quicker for them to do it that way and then put it together than keep changing the program to say, I want to make a different size duct and I want to change it again, I want to change it again. And it's the same with transitions. If you have a whole lot of transitions, they are expensive because they have to be handmade. So if they can reduce the number of transitions, there's a good saving. So that's something to keep in mind and talk to your clients about, or talk to Philip and Ivan. The next one I've got there is square up the ductwork as much as possible, so that instead of, if you can, well, I know a square duct is going to take up a lot more height than a rectangular. But sometimes if you can run a square duct, it will be cheaper to make because there's less metal involved in making square duct. Yeah, let's reduce the perimeter. And then spiral or oval duct, circular duct. That's quite economical to make and install. I don't know whether Ivan and Philip have mentioned that to you, but again, a round duct is going to be a height issue, but up to about, say, 300 to 400 diameter, you might be able to fit that. Probably after that, it's getting too big, and then you'd have to go to a rectangular. But wherever you can use circular duct, it's economical. Typical size, as I mentioned, minimise the fittings and use straight duct as much as you can. Standard lengths, every job may have a slightly different length of ductwork. Are you familiar with that?
Yes, yes.
Yeah. Use flexible duct to grills where you can, particularly in return air, well, and supply air, obviously. Simplify duct routes, rationalise layouts. I put here, we used to use P3 cushion heads. I don't know whether you're familiar with those. It's a prefabricated panel. Do you know that?
No.
Okay, well, you have a cushion head on a supply air diffuser.
Yeah.
Or you might have it on return or exhaust. P3 is it's like a prefabricated insulation panel that they cut and make into a box instead of using metal. If you use metal, then it's got to be internally insulated or externally, depending on whether it's supply or return. But the P3 cushion heads are much cheaper. But I don't know whether you detail that. They're also much lighter. Like a metal cushion head can get quite heavy when they're large. They're 600 square. They're quite heavy. But P3 is very light and easy to work with on site. But that would probably be the choice of your clients, I suppose, the contractors. Anyway, so on and so on. I can send you a copy of this too if you'd like it, just to have a look through, see if you've got any questions. Insulation has to comply with the NCC, obviously. We're going to talk about that a bit more because I think you asked me once before about insulation types.
Yep.
You want to have a talk about that, so we'll come to that soon. Fire rated duct, rationalise that as much as you can because fire rated duct is very expensive.
I think we need to discuss also when to use fire rated, where, when, and how. Probably the next topic because I don't know about much that when to use a fire rated duct.
Okay, well, do you want to talk about it now or?
Yeah.
Okay, well, I'll give you some examples. It's probably the easiest way to start. If you've got, say, a smoke exhaust duct passing through an occupied space, well, in the fire compartment that it's running through, it doesn't have to be fire rated, but as soon as it goes into the next compartment, it has to be fire rated because you can't use a fire damper in a smoke exhaust duct for obvious reasons, because if you're trying to exhaust smoke, you don't want the damper to close. You want to keep it open. So the fire rated duct takes the place of a fire damper. And then from after you come out of the fire compartment, until the ductwork leaves, or until the air leaves the building, all that ductwork will need to be fire rated because it's gone into a separate fire zone. But if you go into a riser, if it's a fire rated riser that goes up the building, then you don't have to apply fire rating to the ductwork in that riser because it's a fire separated compartment from the rest of the building. But you can't have a smoke exhaust duct in with other ducts in a riser. It's got to be a separate riser. So the same thing applies with kitchen exhaust. So you're coming out of a kitchen. Quite often a kitchen is a fire compartment. So as soon as you leave the kitchen, then the duct has to be fire rated. Okay, because the kitchen is probably the main source of fire in most buildings. If you have a kitchen area, that's where the fire is going to start normally, unless someone lights a fire. But hopefully nobody's stupid enough to do that. But so kitchen exhaust is another important one. Stair pressurization. The stair pressurization is done in a number of ways, but the air that comes from outside to your stair pressurization fan has to be fire rated. Now, if you can have your fan at the top of a stair, for instance, or in an enclosure at the top of the stair, and that's got an opening to the outside, then that's a separate compartment and you don't need to fire rate it. But if you've got to bring the air to the stair pressurization fan through the building, then that has to be fire rated. And it's got to be separated from everything else, because if there's a fire in the building, you don't want the fire affecting the stair pressurization air, because obviously that's for people to get out of the building.
Yeah.
So that's a few examples.
Mm.
And basically it's like another example is if you have a fire pump room. Okay, fire pump room has to be a fire rated compartment, because in the pump room you have the pumps that pressurize the hydrant systems for firefighting. Okay, so if there's a fire, that room has to be separated from the building so that those pumps can continue to run. They don't want that part of the building to get on fire and the pumps fail and they've got no water. The fire brigade has to have constant supply of water so they can fight the fire. But fire pump rooms have to be ventilated. Okay, so you've got to get air in. You've got to get air in and air out.
Yep.
And so the ductwork, if you've got ductwork, ventilation ductwork within the fire pump room, you don't have to fire rate it because it's in the pump room. But anything outside the pump room, so the air coming in from outside, if it's ducted in, it has to be fire rated, because you can't use fire dampers, because if a fire damper closes, you've got no ventilation. So that duct has to be fire rated so that you've got a guarantee that the air coming in won't be stopped. And on the exhaust side, because you're going out of the pump room, relieving the air and going through other fire compartments, that has to be fire rated as well. And again, you can't use fire dampers, because fire dampers will close if there's a fire or heat. You don't want that. You don't want that to happen. So basically, your fire rated duct is taking the place of fire dampers.
So basically, we need to fire rate duct, especially those like fire life system, like Serpress, like those one that is running on a fire mode, those system running on the fire mode, right?
Yeah.
And especially those also those ducts that will create fire, like kitchen exhaust. Am I correct?
Yes.
Yeah. Okay.
Yeah.
Regardless with the thickness, is there like NCC required, or like the type of material? Is it the thickness of the fire?
Well, there's not really, no, not NCC. Basically, you've got to provide AS 1668 Part 1 is the code that covers those requirements. And it depends on the fire resistance level of the building. But generally, it's usually 2 hours. So to get a 2-hour fire rating, there's a few ways you can do it, but the most common ones are you can spray a material onto the duct. Okay, have you seen any of these applications?
No, but I only know like the fire wrap it like a wrap the ductwork. Yeah. But
So the
spray I
fire wrap
haven't yet.
is like an insulation that you can wrap on, and that's by far the easiest way to do it.
Is it the cheapest one? Cheapest one, the fire wrap, or?
Probably not the cheapest, but it's by far the easiest way of doing it. I'm not sure of the current costings. You'd have to check with Ivan or Philip about that. But it seems to be now pretty much the industry standard way of doing it. Because it's cleaner, it's easier, it's less disruptive to work on site. Back, say, more than 10 years ago anyway, fire rated duct was always sprayed. It was like a concrete mixture. And so they had to partition off an area that they were going to spray, because it's very messy. It goes everywhere. Have you seen them spray pools when they spray the concrete into a pool? It's like that. And they spray the duct all over, and it's about 50 millimeters thick. Makes an awful mess.
Are they not gonna spray it first before they install, or they gonna install it first and spray?
they have to install it first, because it's got to be a continuous
Spray.
spray. You know, they
Mm.
can't have joints in the ductwork and then have to join them with the spray on it. So that it's
Ah.
all, the ductwork is all finished to a certain point,
Mm.
and then they spray the whole section of duct.
Mm. Yep.
With fire wrap, I suppose they can pre-insulate it on the ground, but then they
Mm.
still have to seal the joint. So when they put the duct together, they'd have to go back over that. So that they're more likely to install the ductwork and then put the wrap on afterwards, where they can do the whole thing.
Mm.
The thickness of the wrap, from memory, is I think it's about 50 millimeters. But you also have to remember that sometimes in an air conditioning system, the fire wrap may also be the thermal insulation.
Mm.
So it has to comply with the NCC thermal insulation requirements.
Yep.
So if it's an exhaust system,
Mm.
there's no requirement for insulation, but there's the requirement to achieve 2-hour fire rating.
Mm.
Okay, but if it's a supply system, and that might happen, that you, and if you've got a complicated fire hazard management, smoke hazard management system, the supply duct may be fire rated. It just depends on the building.
Mm.
For some reason, if you're going from one fire compartment to another, I'll give you an example. If you've got a system where you're a sandwich pressurization system for a multi-story building, or a very large floor plate, like a hospital. We did a hospital that had about 10,000 square metre floor plate.
Mm.
It's very big hospital. And each compartment, each floor had several fire compartments.
Mm.
So we had to get supply air into those compartments and then exhaust out. Okay.
Mm.
So when you have to keep supplying air in fire mode, but it's passing through another compartment, and a separate fire compartment, then that duct has to be fire rated.
Mm.
Because you want it to keep running in a fire mode.
Mm. Yep. Yep.
Okay? So once
Yep.
again, just think about, can we use fire dampers? Well, no, because you want it to keep running. So it's got to be fire rated. So if you can't use fire dampers, you have to fire rate it.
Yep. 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 Got it.
Yeah, okay. It's a bit hard to explain because every job is different.
Yeah.
And they've all got to be treated on their merits and the way the building's being designed and the fire systems that go into the building. Now, here's another question. Have you had a look at the NCC Part E or Section E?
No. No. I'm always focusing on J, but I don't know E.
Yeah,
Is it about the fire? Like
yes, it's the title of that section is Smoke Hazard Management.
Mm.
And every building, well, if you work on a small building, you don't need to worry about it because it won't apply. But when you get into more complex buildings or multi-story buildings, then you do have to consider the requirements of Section E. And it'll talk about stair pressurization, smoke spill, all of those things, depending on the type of building and the height. Now, here's another question for you. Now that we're talking, I don't want to take up your time. If you're too busy, just tell me and I'll shut up. But
No, okay.
with the NCC, have you had a look at classification of buildings?
Yeah. Yeah. Class
Okay.
2, class 3, up to class 9, I think.
Yes.
Right.
Okay. So with a residential building, they're normally class 3.
3.
If you're working on an office, it'll be class 5. Shops and supermarkets and things like that, class 6. Shopping centres. Car parks are class 7, I think, and so on. Hospitals are class 9. They all have different requirements. And in Section E of the NCC, it tells you the smoke hazard management requirements for the different classifications of buildings and for the different sizes of buildings. So it might be a class 6 shop, but it's only a very small shop, so maybe you don't have to do anything. But if it's a shopping centre where you've got supermarkets, specialty stores, big bulky goods stores, and all that, the whole thing changes because then you have to have a smoke hazard management system because you've got a lot of people in the building. If a fire breaks out in one of the shops, then you need to make sure that everyone can escape and you get rid of the smoke. So that's something to be aware of now because that's always relevant. And I put it in, if I just bring up, where are we? This one here. Can you see that where I've marked up your process sheet?
Yep.
So we've got design brief. Now review requirements of the NCC, Australian standards and the building permit if necessary. So by that I mean, it's not only section J, are there requirements under section E, for instance, for smoke hazard management? And then, so I've said here, the next step, prepare a schedule of air conditioned and ventilated areas. So for small jobs, you may not even need to do that because you know exactly what you're going to do. But for a larger job, you might want to have a schedule and get that approved. You might have to say to the client, this is what we're proposing to air condition. Do you agree? And the next one I've got there is prepare a schedule of smoke hazard management requirements. And this is, that's section E of the NCC. So you might, when you have 10, 15 minutes to spare, have a look at section E and just see what it says. It talks about pretty much buildings that are less than 25 metres high and buildings that are more than 25 metres high. Once you go over 25 metres, then everything kicks in, like stair pressurisation, smoke spill. But depending on the type of building, you might have to do it if the building is less than 25 metres high. And so on. So that's, if we go back to this one. So I'm just trying to sort of give you an idea of the things you need to think about without throwing too much on your plate at the moment. And back, we were talking about VE, so we'll just go back to that. Where was that? So just to finish off the VE, we put there, use metal strap to hang duct where you can. And you're probably already familiar with that. There's an Australian standard for supporting ductwork, and metal strap is acceptable for certain sizes, not for all sizes. When you get over a certain size, you have to use angles, steel angles. Site measures is something, have you discussed those at all with Ivan and Philip? Do you know what I mean by site measures?
I think we will be using site measure if it is existing building, like the last one, if we don't have data much.
Yes.
And the last like connection details, because it is existing. Most of it is existing.
That's fair enough. This was one thing that used to be, we used to try very hard not to totally eliminate them, but to really minimise them because it's quite expensive to make site measures because the process with that is that the tradesman on site has to measure, everything that he needs, the length and the angle and all that. And that's got to go back to the factory. They have to hand make it and then send it to site. It slows down the process on site as well because they can't finish the job until they get the site measure made. So it might take a week before they get it back from the factory to install it. So they've lost a week. They've got to go on and do something else, and then they've got to come back again. So it just takes time. And we're trying to make the site work as efficient as we can. But I do understand that there are some times when you have to do it. So, and that's okay if you have to do it. But anyway, just keep that in mind. Flexible duct for transfers in lieu of rigid duct. Sometimes that's you can do that.
Mm.
Instead of having a solid transfer, you can use flexible duct,
Mm.
depending on the situation and the acoustic requirements. And single blade dampers for small ducts. Instead of having a damper made with multiple blades, it's just a single sheet metal blade. Have you done that? Yeah. Okay. All right.
But how big, what is the maximum size of ducts that I could use a single blade dampers? It's like 300 or I don't know.
Yeah, that's a good question, and different companies will have a different answer for that. But we used to say, probably up to 400 wide by 300 high or something like that. Above that, they get a bit they're too big and they vibrate and they don't control very well. But for small ducts, they work all right. So 400 by 300 would be okay, probably up to that size.
Yeah.
All right. So that's probably as far as I was going to go today. But have you got any other questions?
No, I think I just review. I think I don't have much question right now, but looking at that one, I can prepare some questions on the other
Yeah.
topics that we could. It's
Yes.
basically
Okay.
most of it. I think I have already experienced on those one, but I need like a deep explanation on what is the best practices, like fan selections. I don't have much. I know how to input the data, but don't know what is the best way to select a fan, like requirements, like a best practice.
Okay.
Yeah.
Well, that'll be a good discussion. We'll talk about
Yeah.
that next time.
Yep.
I suggest if you have 15 minutes to half an hour to spare, just have a look at the NCC and understand the process going through that. So you know how to how to work out the classification of a building. Excuse me a second. Got the drink. So from there, have a look at section E and just don't try and understand it in detail. It's quite complex, but just understand that there's a section for less than 25 metres, higher than 25 metres, and see what the requirements are for the different types. But don't worry about trying to understand it all at the moment. Just be aware of it. And if you've got some questions on that, bring them up next time and we'll go through that as well.
Yeah.
So I think this is probably the best way. We just work through a few points, see what questions come out of that, talk about that, and then move on a bit more.
Yeah. This is the best way, process that we will be doing on the next trainings, and probably need to catch up. And
importantly, I'm trying to make it relevant to you. I don't want to tell you a whole lot of stuff that's not relevant at the moment. If there's anything you're working on at the present time that you want to talk about, we can go through that too. If there's any questions on the stuff that you're actually working on, let's deal with that so you can get that done. But other than that, we'll keep working through this list, and I'll give you some references to have a look at when you can, and then you can ask me some questions.
Yeah. Okay.
All right, that sounds good. All right.
Thank you, Peter.
Okay. We'll see you next week.
Yeah. Bye.
All right. See you, Simon. Bye.
Hello.